Direct variation here. So first, before we get into exactly what direct variation is, I want to provide an example for you, a real life example of direct variation. Okay, the last time, we haven't had thunderstorms for a while, but the last time we had a thunderstorm, let's say you see a bolt of lightning come, and then you wait 10 seconds, and all of a sudden you hear that thunder. Okay, so you hear the thunder. So let's see, you waited 10 seconds, and before you heard the thunder, and that tells you basically there's a relationship between the time that elapsed and the distance you are away from the lightning bolt. So that's telling you that you are about 2 miles away. Okay, let's say, okay, you hear another bolt of lightning. So you hit another bolt, and this time you waited and you saw the bolt, but then it was 15 seconds. Okay, and that's going to tell you that that is going to be 3 miles away. Okay, this is an example of a direct variation. Okay, so what I'm going to write down here is the time it takes to hear thunder is no, I wrote that wrong. Varies directly. Varies directly with the distance from lightning. Okay, so let's just talk about a little bit more about how it varies. So if we were to think about it varies directly, it means there's a direct relationship between, okay, it's 15 seconds, it's 3 miles, 10 seconds, it's 2 miles. So what would it be if it was 5 seconds? It would be 1 mile, right? And if it was 20 seconds, then that would be that's 4 miles away, okay? So there's a direct relationship here. So basically, if you take your input, which was x, we're going to let x be the time, and we're going to let y be the miles. There's a direct relationship between these, so we're going to be able to say, okay, y is equal to, well, we'll come up with how I got this later, but we're going to be able to say if I take 1/5 of the number, if I take 1/5 of 5, I get 1. If I take 1/5 of 10, I get 2. If I take 1/5 of 15, I get 3. 1/5 of 20, I get 4. So this is a direct relationship. You can see right here, there's a direct relationship between x and between y. Okay, so as we move onto the next slide here, I want to talk about how you identify if something is a direct variation or not. So for example, let's just define what direct variation is. A direct variation is a relationship that can be represented by the function y equals times f times x, or it's more common to put k of x there. So y times k times x, okay, period. So basically, if something's a direct variation, there's a direct relationship. You're going to multiply x times something, and you'll get y. There is no plus sign over here, okay? It's just k times x. If it was plus 2, it would not be a direct variation. So let's look at some examples here. Let's look at if something is a direct variation or not, okay? So let's look first at 7y equals 2x, and we're trying to determine if this is a direct variation or not. Well, if I divide by 7 and I divide by 7, we'd get y equals 2/7 x. So yes, this is a direct variation, yes. And what we call this 2/7 out front is the constant. It is called the constant of variation, okay? It's the number in front. It's what it varies by. In this case is 2/7. So you take the number out front. Your constant of variation is 2/7 because this x varies directly with y by a constant of variation of 2/7. Okay, so if we look at another example, I could look at something like 3y plus 4x equals 8. Okay, so then I could say 3y equals negative 4x plus 8. Then divide both sides by 3, and y is equal to negative 4/3 x plus 8/3. Okay, and now this is not a direct variation because we have this plus 8/3 over here, so it is not a direct variation. Okay, so you can't have, it is not in that form up there of y equals some number times x. We have this piece right here, 8/3 makes it not a direct variation.